For the next 3 problems, once you have given it a try, continue the video to look at the solutions. In part 8, we have things in factored form already, and this is again another example where we have y minus 9 on top and 9 minus y on the bottom. And once you have done enough of this, you'll recognize they are negatives of each other. But if you don't, we can always take this extra step of rewriting the denominator. And if we rewrite the denominator in decreasing order, that would become negative y plus 9. And when the leading term is negative, we want to factor out the negative sign, and that becomes y minus 9. That's a negative expression over here. And once you see this, we see y minus 9 cancel each other out, and we're left with a factor of negative 1. And they're indeed negatives of each other. And once you're fluent with this process, you can directly do a cancellation from the very beginning and just carry a negative 1 as a factor. And as a result, we would write negative y minus 3 as a final expression over here. We don't actually need to write the denominator being 1 anymore, because anything divided by 1 is just going to be the expression itself. And that's the final answer. Now looking at the second expression over here, I actually noticed that we have some different variables involved. I'm going to go ahead and change this t to be an x, because we have a function of x over here. And here, g of x. On the top we have a linear expression. We can't factor that anymore because we don't have any GCF. And then on the denominator, I have a quadratic expression. If we look at the factoring, we want the sum to be negative 30 and the sum to be positive 1 and product to be negative 30. If you go through your factor pairs of negative 30, you should see that the two numbers we have is positive 6 and negative 5. Make sure you're careful with the signs over here, because we want the sum to be positive. And once we do so, you will see x minus 5 is a common factor on top and bottom. And we would just have x plus 6 left on the bottom, and on top we have everything cancelled out, so we're left with a factor of 1, because 1 times x minus 5 retains its own value, and that's going to be the reduced form. Lastly, for h of r, we again start from the top to check GCF, and anytime we want to start a factoring, GCF is where we always want to start. On top we have r squared as a GCF. That leaves us 5r plus 3. On the bottom, we again want to check the GCF. We see that r is going to be the greatest common factor, which gives us 5r squared minus 22r minus 15 over here. And in this case, actually before we even fully factor things, you will see that we have r squared on top and r on the bottom, so we can cancel out one of the r's from the top, and this r in the denominator is cancelled out for now. Now continue on, the top is just 5r plus 3. We can't do anything for now. On the denominator, we have this quadratic expression that we want to check for AC method. And here we want the product to be a times c, which is 5 times negative 15, or negative 75, and the sum is equal to negative 22. Again, if you went through the factor pairs of negative 75, you will see the two numbers are negative 25 and 3. So that's what I'm going to do. I'm going to rewrite negative 22r as negative 25r plus 3r. And then carry the negative 15. So next step, the first two terms go together, last two terms go together, connected by addition. Once we have this form, we would want to do factor by grouping. If we check the first group, the GCF is 5r, we're left with r minus 5. Second group, GCF is 3, left with r minus 5 again. So once we do that, we will see on the denominator, we actually have a factored form. r minus 5 taken out as a common factor, 5r plus 3 is what's left. And then we have another cancellation we can do with 5r plus 3, and that leaves me with 1 over r minus 5. Don't don't forget the 1 on the numerator. It's really important.